Okay, class, welcome to the first PowerPoint for learning outcome number 1 for Math 2015. Okay, so what we're going to do is we're going to go through this PowerPoint and go ahead and watch, and you can take notes as we do this. Feel free to pause the video when I say pause the video to try out some activities, and then we can compare like how they went. So the first learning outcome is part of the first unit, which is on the equal sign. And we're going to differentiate between operational and relational understanding of the equal sign. Okay. We want to explain why the relational understanding is preferred. Okay. So going on through the next slide here, we want to fill in the blank. So I want you guys to pause the video and fill in the blank with what you think should be in the blank. Okay, now that you've resumed your video, we're going to see that 3 and 4 could equal 7, right? So how many people wrote 7? Why? So if you wrote 7, think internally why that you wrote 7. Easy addition fact, right? Well, how many possible answers are there? Okay, I want you to pause the video and then think of 2 or 3 more examples of what could be on that side of the equal sign. Does it have to be 7? Are there other things that are equal to 3 and 4? Okay, now that you've resumed your video, we're going to see that there are indeed perhaps many more things that could equal 3 and 4. Okay, so we're going to go back to this one right here. 3 and 4 equals what? We can also say that 3 plus 4 is equal to not just 7, but like something that's the same as 7, like 4 and 3. 3 plus 4 could equal 5 plus 2. 3 plus 4 could equal 5 plus 1 plus 1. Okay, so you can extend your thinking to many possibilities. Okay, and moving on, what does that symbol mean? Okay, this is the equal sign. Okay, equals. It means the same as. Okay, that's a good way to start here. The same as. Okay, so that's what the equal sign means. So you have this part of this equation with this part over here. 3 and 4 is the same as 7. Okay. Well, what goes in the box? Let's see what we can put in the box. Now, when we put a let's see if you guys go ahead and pause the video. What do you think should go in the box? Okay, now that you resume your video, let's see where we can go. In a classic study, no more than 10% of the students said 7. Okay, so 10%, a very low number, said 7. Okay, that's what they think went in the box. Well, why is 7 going in the box? We think that 8 and 4 make 12, right? So we want to assign a numerical value. They make 12. We need this right here to also equal 12. And the only thing that can be equal to 12 is if this is 7 right here. Okay, so 7, 8 and 4 equals 7 and 5. Well, no more than 10% do put 7 in there of the students. Okay, what do you think they do put in there? Okay, common answers could be 12 and 17. Okay. Well, why could 12 be in there? Why could 17 be in there? Now, 12 could be because 8 plus 4 is equal to 12 if you just consider this part and this part. But this is the non-relational operational understanding of the equal sign, okay, as we found in the reading. Operational means that I'm going to operate on these two numbers, 8 and 4, and set them equal to 12. Okay, this is an operation. But with relational understanding, we take 8 and 4 and we see, well, that's the same as 12, but it's also the same as 9 and 3 or 7 and 5. Okay, so we need 7 here to be that relational, make that relational understanding happen. Okay, they're relating these two things together. They're not operating on them. What does this mean about how students view the equal sign? Okay, remember that this is the study from no more than 10% of the students would say 7. Okay, they view it as do something symbol. Okay, I'm going to do something, I'm going to operate on them. But it's not. It's really relational. They're the same as. Okay, the same as. Okay, so let's take a look at some student understandings with these ones. What do you think a student will say when they see the equation 8 equals 4 plus 4? Okay. What do you think they'll say when they have the operation of, or the statement, equation statement, 3 plus 2 equals 4 plus 1? Or what about 7 equals 7? 3 and 3 equals 8. Okay, what do you guys think about these things? Now that you've had a minute to think about it. Okay, this is, let's see what the student says. Taken from CPALMS, which they did some studies with some students about relational understanding. Okay, and here's our problems again right here. Okay, and he's going to answer them on this video.
8 equals 4 plus 4.
Okay, is that true or not true?
Not true.
Why is that not true?
Because the equal sign can't be the first thing
Okay.
behind the first number.
Gotcha. Okay, let's look at the next one. Read this one to me.
3 plus 2 equals 4 plus 1.
Okay, is that true or not true?
Not true.
Why is it not true?
Because you can't have a plus behind an equals.
Oh, so this one is behind over here?
Yeah.
Okay, let's look at this one. Read that one to me.
7 equals 7.
Is that true or not true?
Not true.
Why is that not true?
Because there has to be a plus or a minus.
Oh, need a plus or a minus somewhere in there, huh?
Yeah.
Okay, what about this one?
This is not true because the equation is not correct.
Okay, what's not correct about it?
The answer.
The answer. What should the answer be?
6.
6. Oh.
All right, wasn't he cute? So here's how they typically answer at the beginning of this grade, and we're going to go ahead and see what they do next. Okay, here's the same kid. Here's after he's done with his grade. I think it's in 2nd grade. Let's see how he does here.
8 equals 4 plus 4. True.
Why is it true?
Because even though the equal sign is in front of the plus sign,
Yeah.
it's still, because 8 still equals 4 plus 4. 3 plus 2 equals 4 plus 1. True.
Okay, why is that true?
Because 3 plus 2 equals 5, and 4 plus 1 equals 5, and 5 equals 5, so that's true.
Excellent. Okay, read this one to me.
7 equals 7.
Okay.
True.
Why is that true?
Because 7 just still equals 7.
It does?
Yeah.
So what does this equal sign mean, do you think? Tell me more about this equal sign.
It can be anywhere.
It can be anywhere. As long as what?
It has to be right.
It has to be right. So what do you mean by right? What about each side of it? What do they think they have to do?
They have to be the same. It's that equation.
Okay, if it's that equation, it has to be the same. Okay, so read this one to me.
3 plus 3 equals 8. Not true.
Why not?
Because 3 plus 3 equals 6. If it was 3 plus 3 equals, 3 plus 3 plus 2, that would be the right equation.
It would be true then, huh?
Yeah.
Okay, what do you guys think of his thinking as he reasoned about these equations as they evolved over the school year? Great progress, right? And so this is kind of like what we want our students to be able to do throughout the grades, okay? And this is an addition example, but we can also do it with multiplication or division, thinking about these in very flexible ways with the equal sign, okay? So notice that the equal sign is not the do something operation. We want the relations between them, okay? Relation of this side and this side. The relation of this side and this side, they have to be the same, okay? So it's the same as. And so hopefully that when you get to be a teacher, you'll be able to know that this is something that students run up against a lot, and that you can do some cool activities to help them become like this boy here. What do you think of when you see the symbol equal sign? Okay, the equal symbol. Do you think of the same as, or do you think of it as a do something symbol? One of the most important symbols in elementary are arithmetic, algebra, and in all mathematics. Okay, one of the most important symbols. We have algebra, arithmetic. Okay, so we're preparing our students for algebra in these early grades, throughout all grades of elementary school work, and we need to have them think flexibly about the equal sign. The reason why we're doing this is that we can make the jump from arithmetic to algebra a lot smoother if we do this work beforehand. Okay, so they need help understanding and seeing that these symbols in our number system, how they relate. The equal sign, you also have the less than sign. Okay, you also have more than, the greater than sign. They need to know that they represent quantitative relationships. It requires them to see both sides of the equal sign. Okay, so that flexibility is important for them to know and see when they see the whole thing, not just a right to left, or left to right type operation. Okay, equivalent expressions, and you see them as the same. Okay, understanding of the equal sign. Operational is the do something signal. The answer is, or what comes next, or the total. Okay, so those are things that focus more on the operation. Okay, so sometimes you do need to think about it like that, but you also need to see about the relational part. Okay, relational is the same as. Okay, same value or same quantity. The left side is the same as the right side. Okay, those are relational views. The algebra's golden rule: what you do to one side of the equation, you must do to the other side of the equation in order to maintain that balance. Okay, that has to be balanced, so it's the same. Why does it matter? Let's take a look at this interchange. Okay, so take half of 2n plus 2. Well, I can't. Why not? There aren't two sides. I'm confused. If it was 2n equals 2, then I could, because I could do the same thing to both sides. Okay, so this is what they were thinking. Okay. Attenuate to the equal signs. So here's like an algebraic expression. Okay, so you can take half of 2n plus 2 here. Okay, and so notice that when you do that, make sure that this part is equal to this part. Okay, so what we do in algebra a lot is that we take some from here and some from here, but we need to make sure that we can do some from both of these terms, okay, around the plus sign. By factoring out a 2 from this one and this one, we get it here, because 2 times n is 2n and 2 times 1 is 2. We can simplify this by taking separating out the 2 over 2. The n plus 1 is what's left in the numerator. The 2 divided by 2 become 1, and 1 times anything is anything. Okay, so that's kind of a step-by-step process to attenuate to equal sign when you're quote-unquote canceling. Okay, so you need to cancel from both of these. Okay. So if you can do this process, then you can take 2 from both terms, from all the terms in there. Okay, and so with this one, we're going to skip that. And then we have our homework. Okay, so we're going to make sure you begin your fluency journal, and make sure that you can do these homework packs 1 through 3 and then 4 through 7. Okay, and if you want to take a look at these, that's fine, but it's beyond for what we're going to do for this course. But mostly we're just going to do a reading and attenuate to equal sign. All right, I hope you enjoyed this lesson, and I hope you have a great week.